What's up, Algebra 1? In this video we're going to learn how to graph a quadratic when there's a horizontal stretch. So we're always going to compare our graphs to the parent function of y equals x squared. So here we go. So in example 1 we are going to graph y equals 1/2 x squared, and we're going to compare it with the graph of y equals x squared. So we have a graph right here, and I'm going to select default x's to try to figure out what my points are for my y. So if you have a graphing calculator, you can actually use that and immediately get what your x and y points are going to be. So I selected -4, -2, 0, 2, 4. They're pretty symmetrical. I mean, I don't know if these are the best points, but I just would start with that at least. So when I substitute the -4 into the x, so I'm squaring -4. So -4 times -4 ends up being a positive 16. So I'm going to do that with all of my points of -2. I should get 4, 0 squared is 0, 2 squared is 4, and then 4 squared is 16. So at the right, I'm going to graph what I can. So at -4, positive 16, I'm not going to be able to graph that positive 16, but I know that if I were to envision where the shape of the graph would be, I know that my 16 would be way up here. So it's kind of going to come down eventually. So then -2, 4 I can graph, so that -2, 4 is right around there. And then 0, 0, 2, 4, so over 2, up 4, so it would be pretty much on the opposite side of this point, right here. And then finally 4, 16, again I can't really graph that. Okay, so if I draw my line, not line, but my curve, we're actually going to draw something called the parabola. And when you draw your parabola, you can't draw a V. So you're going to have to show some kind of curvature, imagining that there is a 16, -4, 16 graphed up here, and you're going to graph it and make sure that there's a curve, not necessarily a V at the bottom of this point, which is called the vertex. So slowly drawing it up and imagining that it's going to continue past this point and up to 16 somewhere, and then to the other side. Just like so. So we do have to draw the arrowheads to indicate that we're going past this point that we graphed, and somewhere it's going to go to 16. Now, when we graph y equals 1/2 x squared, we're going to see something a little different. So I'm going to use the same points when x is -4, -2, 0, 2, 4. What my y value is going to be, I'm going to figure that out. So I'm going to square -4. So I get -4 times -4, which is 16, and taking 1/2 of that, which is going to give me 8. Okay, so -2 times -2 is positive 4, divided by 2, you get 2. And then 0 squared, which is 0 times 1/2, is still going to give us 0. And then, if you kind of see the pattern here, we should get 2 when x is 2, and we should get 8 when x is 4. So when we graph these points, we can actually graph this on our coordinate plane on the right. So we have -4, 8, so -4 to the left and up 8. Oh, it's right here. Actually, I missed it. Sorry. -5's here, -4's here. So -4 up 8, -2, positive 2, which is right here. 0, 0. So the vertex is the same spot. And then to the right 2, up 2. And then finally 4, positive 8. So if I connect my dots, not in a line, not making a V, we're going to draw a curve, so a nice parabola. You can notice that the vertex is in the same spot, however, it's a little wider than our parent function. And because it's wider, the reason why it's wider is that we're actually multiplying the parent function by 1/2. So a number that is definitely less than 1. Regardless if it's positive or negative, if this coefficient of x squared is a fraction or a decimal that's less than 1, your graph is going to be horizontally stretched. So when we compare it, we have that 1/2, we can say that the graph is horizontally stretched, period. So that's the effect of that coefficient that is in front of the x squared. If it's less than 1, we're going to have a graph that's horizontally stretched compared to the parent function, like so. Alright guys, thanks for watching. Make sure you stay tuned for part B of this segment, where we can see that the graph will have a vertical shift.